Okay, as we approach the next major milestone in our project, let's take a step back and take a look at what we've gone through in these opening 7 weeks that have allowed us to create an architectural design document as part of our project going through. So generally, each of you started with a system and having a system in mind. So that's really what we have going on here. You picked a system back in the Unit 2 assignment and you worked forward from there. So the first step you had to go through to identify your system was identify who the owner was. The owner is the person who can dictate whether the system is a good system or not, and typically approves it or validates it in some way. So if you want to know if the system meets the need, you go ask the owner as you go through. So the owner is usually someone in management somewhat above the functionality that's being implemented by the system that's in question. From the owner, you obtain the high-level business rules and the business requirements that they expect a system to meet. So largely, the business requirements help set the scope. The things the business owner says are the requirements tend to define the scope of what you're trying to do as you see your way through. The business rules are additional items the owner states that are more like the laws of physics to us as engineers. They're things we must meet and rules we must obey in our system, but they're not negotiable. They're not requirements that can be prioritized or partially implemented, things of that nature. They're things we absolutely have to do as we go through. So once we let the owner pin down the scope of our system through the business requirements, we can then ask ourselves, well, who are the stakeholders for the system? Who has a stake and who can help judge whether or not this system is a good idea? Who uses our system in some way or interacts with our system in some way such that they don't have to? If it's not a quality system, they can walk away typically. These are stakeholders who are involved in your system process, but that you don't necessarily control them as you go through. So they're not necessarily the operators or users of your system. They might be, but they're stakeholders who have a stake in a valid system helping them do something or meet some set of requirements. So we often then go straight into defining their requirements. We take the perspective of the stakeholder as well as the scope defined in the business requirements, and we just define a set of stakeholder requirements for each stakeholder as we go through. So this was all happening back during the system conceptualization. As we do that, we might find some non-functional requirements at the same time that will support some of our business requirements, the ilities, the reliability, the maintainability, the testability, the ease of learning, the usability. Those requirements might come up as you're going through the conceptualization of your system. I've included a dotted circle here because if they don't come up here, that's okay. You'll get them in the next phase, but they might come up as you're doing your conceptualization of your system. Likewise, you should be looking for any given system as what is it trying to manage? What are its nouns, basically? What is it managing as it goes through? What are the main stocks of things going on? And what's flowing in and out of the stocks? So ideally, for any given system, we make up a very, very comprehensive list of all the things the system is trying to manage as the stocks of things that are going on. From the flows against those stocks, we can start to derive the functions that we want in our system, because every flow in a stock and flow diagram must be a function somewhere in your system to make that flow happen. So again, dotted lines because we're not really after the functions at this stage. What we really want during conceptualization is to understand the functions well enough to be able to identify the actors and the use cases. Actors and use cases is what we're after during conceptualization. But if you don't explore the stock and flow and come up with some functions, just try to brainstorm actors and use cases, the list you'll end up with is always wrong. Always. You want to anchor your use cases in functions you expect the system to perform. So use cases without any knowledge of your functions, you'll pick things that aren't really use cases, you'll have things that are in your scope, you'll miss a lot of things that are in your scope. So try to ground your use cases in a preliminary functional list, and from that you get your actors. Actors are people who come and interact with your system for some purpose. The users, operators, and yes, maybe stakeholders. So there may be an overlap between the stakeholders and the actors, but not necessarily as things go through. An actor is someone who approaches your system for a stated purpose, and that stated purpose is a use case. All use cases are driven by functions, but not all functions are use cases. It has to be something that the actor would approach to do something. So it's not the steps of what happens while the actor is interacting with it. It's the aggregate transaction or event that the actor is trying to manage. So ignoring the dotted lines, because you don't necessarily have to have them in that stage, all of this goes into your system conceptualization, which was our Unit 4 deliverable in terms of our project. And it's something you're updating in your Unit 7 deliverable. I expect the conceptualization of your systems to be much, much stronger, more thorough, more complete than they were back in Unit 4 as we move into Unit 7. So it's still on the concept diagram because you're still working on all of these things throughout the life of your system. But as we move on then, the non-functional requirements and the functions get fleshed out as you move into your preliminary design. The focus is really on non-functional requirements and functions. Non-functional requirements often drive the need for more functions. So if I have a non-functional requirement for the system to be easy to learn, that I'd better find training functions or documentation support functions in the function list that would be determined to support those non-functional requirements. So non-functional requirements are non-functional to the extent that the requirement itself isn't for a given function, but they tend to imply a lot of functionality as you're going on. So expect your non-functional requirements to drive many additional functions into your system. And then your business requirements, your stakeholder requirements, your non-functional requirements, and your functions then are used to drive and define the functional requirements. Define a set of requirement statements for every function that comes out going through, as well as your non-functional requirements. But you're really driving non-functional requirements into functions. So really functions drive the functional requirements as you go through. So a given system that has 4 or 5 stakeholders, each of whom have 10 or 20 stakeholder requirements, might have 50 to 100 or more functional requirements against 10 to 30 functions that are considered the key functions of a given system I'm going through. And functions get broken down into sub-functions and further down. So you want to treat your functions as a hierarchy, really drill them down into all the steps that are needed to fulfill the use cases and the stakeholder requirements that are driving your system going through. If you get that far, you've really got your functional architecture, the first half of your preliminary design chapter for your deliverable. What's still lacking is the technical architecture, the physical architecture for your system going forward. And that gets completed by developing your components that will implement your functions. Sometimes components and functions are one-to-one, but not necessarily. It could take multiple components to implement a function. You want to, again, drill your components down into a hierarchy. Eventually, you want your components defined to a sufficient level of granular detail that each of the most detailed functions, those that are at the bottom of the hierarchy of components, will be implemented by a single engineering discipline. So this component goes to HR for a job description, or this component goes to HR for an incentive program or a training program. These components go to IT because they're software related. These components go over to mechanical engineering because they're mechanical components of the system. These components might go to electrical engineering because there's an electrical design goes with the hardware as you go through. These parts might go to civil engineering because I've actually got to build a structure or a building or work out a plot plan. So all the detailed components get mapped out to the different engineering disciplines at the bottom of the tree. And that's why systems engineering is about creating the designs that are implemented by lots of different disciplines. As systems engineers, we tend to stay involved on the control and integration, verification and validation side, and we'll move to verification and validation next week. But you want a slew of people working on your components as you go through. So our final job then as systems engineers is to do the system requirements for each of the components that we've laid out in our system, such that system requirements fulfill functional requirements. So at the end of the day, when all of this integrates, I've got system requirements and components that implement every functional requirement and function, which implement every stakeholder requirements for the stakeholders and business requirements for the owners. And the sum of that is the system that I'm working on. So all of this goes together to work out into your system design and your Unit 7 deliverable. The chapter on system conceptualization that came out of Unit 4 is being updated in a major way in this more recent assignment, and the stuff you're adding is the preliminary design, the functional and the technical architecture and definition. This is a very detailed design. Do not stay superficial. There are potentially many dozens to potentially 100 or more functions in any given system, and each of those is going to have several functional requirements. So pay attention to the discussion threads, pay attention to the examples that have been posted both in the discussions and in the activities, as well as in the discussions. So mimic and look at the level of detail we've been talking about in recent weeks. The most common mistake people make on this deliverable is they don't create the level of detail necessary to be a complete design of your system. A given system is going to have many functions and components in it, and it has to be comprehensive to cover all the requirements. So just you want to design the procedures, the tools, the training programs, the support programs, the installation and packaging, or even the shipping if the system has to be shipped. So don't just think about what the core system does. Think about all the pieces from Chapter 2 that have to be mapped around that in terms of training and support and evolution and maintenance of your system going forward.